Welcome to Season 2 of the Carroll-Wells Gradient. In this episode, we reach a question that sits quietly underneath almost all of physics, yet rarely gets stated directly. This is Episode 11, Layer 11, Bridge to Cosmic Persistence, where we examine why the same laws we test in laboratories also govern stars, galaxies, and the large-scale structure of the universe. Why do small-scale experiments tell us anything about the cosmos at all? Why does physics scale? At earlier layers, we followed persistence as it stabilized structure, shaped probability, enabled life, supported awareness, survived collapse, aggregated information, obeyed thermodynamics, and learned to explore safely through modeling. At this point, a pattern should be clear. Nothing in this framework depends on scale. That observation is not trivial. If physical laws changed fundamentally with size, none of this would hold. Laboratory physics would tell us nothing about galaxies. Biology would not reflect chemistry. Cosmology would be disconnected from experiment. Yet the opposite is true. The universe is remarkably consistent. This consistency is captured by a concept physicists call universality. Universality means that very different systems, made of different components, often obey the same rules when viewed at the right level of description. The details vary, but the structure persists. This is why fluid dynamics applies to water, air, plasma, and even traffic flow. It's why phase transitions share common behavior across wildly different materials. Universality is not coincidence. It is persistence revealing itself across scale. Closely related to universality is scaling. Scaling tells us how patterns change, or don't change, when size, energy, or time is varied. Some features wash out, others remain. The ones that survive scaling are precisely the ones persistence protects. When we zoom out from atoms to molecules, from molecules to cells, from cells to ecosystems, and from stars to galaxies, certain informational relationships remain intact. Those relationships are not fragile details, they are stable constraints. Persistence filters what scales. The third piece of the bridge is correspondence. Correspondence is the principle that new descriptions of nature must reduce to older ones in the regimes where the older descriptions work. This is why classical mechanics emerges from quantum mechanics at large scales, and why relativity reduces to Newtonian gravity at low speeds. Correspondence is not just a mathematical requirement, it is an informational one. It ensures that knowledge accumulates rather than resets. Taken together, universality, scaling, and correspondence explain something profound. The same informational rules bind atoms and galaxies, not because the universe is simple, but because only certain patterns can survive across scale without collapsing under cost. Persistence does not care whether a structure is small or large. It cares whether it can maintain itself under constraint. The laws that survive are the laws that scale. This leads us to what can be called the law of persistence across all scales. Structures persist only if they can manage cost, export entropy, maintain internal consistency, and integrate with their environment. That rule applies to chemical reactions, living systems, machines, planets, and cosmic structure alike. There is no separate set of rules for the large and the small. There is only constraint applied repeatedly. This is why laboratory physics matters. It is not a miniature universe. It is a testbed for persistence. At this layer, the bridge is complete. Local experiments inform cosmic behavior not because we assume they do, but because persistence demands continuity. Any law that failed to scale would quickly be eliminated as unstable. The universe does not tolerate inconsistency for long. But this raises a final and unavoidable question. If persistence binds structure across all scales, and if gravity dominates structure at the largest scales, then what is gravity really doing in informational terms? Is gravity merely geometry, or is it the cost of holding structure together across scale? That question brings us to the next layer. I'm Charles Carroll. Thank you for listening to Episode 11. Join us next time as we move into Episode 12, Layer 12, Working Quantum Gravity Ansatz. Gravity as the cost of holding structure together. There we'll explore an intuitive, equation-free way of thinking about gravity as an energetic and informational constraint, and how curvature, information, and persistence may be unified without breaking known physics.